Fall 2021 Exam 3 walkthrough for the course 16010. Let's begin. Number 1. Find the x value at which the inflection point of g of x equals 10x cubed plus 30x squared plus 20 occurs. So when we are trying to find inflection points, we want to use the second derivative. Wherever the second derivative is set equal to 0 is where an inflection point occurs. So let's start by finding g prime. So g prime of x equals the derivative of 10x cubed is 3 times 10, so that's 30x squared plus derivative of 30 plus x squared is 60x, and then derivative of 20, which is a constant, is 0. And then now let's find the second derivative. G double prime of x equals the derivative of 30x squared is 30 times 2, so 60x, and then derivative of 60 is x is just 60. So we have that the second derivative equals 60x plus 60. Now, to find the inflection point, again, we need to set this equation equal to 0. So let's go ahead and do that. If we solve, we get 60x equals negative 60, or x equals negative 1, or the answer of C. As a reminder, an inflection point is graphically where the function would change from positive or concave up to concave down, or vice versa. On the second derivative graph, it's when it crosses the x-axis. Okay, number 2. Which of the following limits equals infinity? So, with this one, we want to look at basically the ratios. So if we look at this first one, there's the powers of the largest power on there is the same for both. So the limit for this one would be 5/6. So if you have the same power on the top as on the bottom, you're just going to get a ratio, and that will be your limit. So it is not A. B, if you look at B, you can see that 2x plus 1, 5x minus 10. Again, it's the same power on the top as at the bottom, so the limit would be 2/5. Okay, number C, or 2x to the fourth minus x plus 1 over x squared minus 8. This has two different powers. So we can use L'Hopital's rule to essentially whittle this down. So L'Hopital's rule basically means taking the derivative of the numerator and the denominator. So for this one, the derivative of the top is 2x to the fourth, so that's 2 times 4, 8x cubed, minus the derivative of x is 1, and then over the bottom, which is derivative, so that'll be 2x minus 8, and then again, do it again, we have 8 times 3, 24x squared over 2. So when we see this is simplifies to 12x squared. As x goes to infinity, this is just going to shoot straight up. So we know our answer is C. So let's go ahead and just look at the other ones. D. With D, you can see that that the top power is actually smaller than the bottom power. If you were to basically L'Hopital, you would eventually get to some coefficient, or 1 over some coefficient times x. Because of this, we can see as x goes into infinity, this will slowly approach 0. So this is an incorrect answer. For E, the top, this one could be deceptive, but if we go ahead and L'Hopital this, it would be negative 2x for the top, and then 1 for the bottom, and then it would be, so that would be negative 2x. As x goes into infinity, this would go to negative infinity, so not exactly what we were looking for. And then for F, again, same as D, the top power is less than the bottom power, meaning that you're going to eventually get to something that looks like 1 over x, which as x goes to infinity, that approaches 0. So again, our answer is C. Number 3, find the largest open interval where the function f of x equals 1/12 x to the fourth plus 1/3 x cubed plus 9x is concave down. So when we're looking for concavity, we want to find inflection points. Similar to the first question, inflection points occur where the second derivative equals 0. So let's go ahead and start by finding the first and second derivatives. So the first derivative, f prime of x, equals 112 times x to the fourth. So that would be 4 over 12 x cubed plus 1/3 x cubed. So that'd be 1/3 times 3, so that's 1. And then x squared plus derivative of 9x is 9. Second derivative, f double prime of x equals 3 times 4 is 12, and 12 over 12 is 1, so this will be x squared plus derivative of x squared is 2x, derivative of 9 is 0. So we're going to set the second derivative equal to 0. The first thing I would do with this one is there's a common factor of x, so let's go ahead and factor that. That would give us x plus 2 equal to 0. This makes the roots super easy to see. As you can see, this would make x equal to 0, and this would be x equals to negative 2. So our inflection points are at 0 and negative 2. For these questions that ask about concavity, it is also really, really good to draw a number line. So let's go ahead and do that. Draw a number line. Put our inflection points, that'd be negative 2 and 0. Now to find where it is concave down, we're going to check here, here, and here. We're going to go and plug in numbers in between negative infinity and negative 2, negative 2, 0, and 0 to infinity into the second derivative to see what that second derivative sign is. So if we do negative 3, so f double prime of negative 3, so we're looking at this first region right there, we would get that f of negative 3, so that would be negative 3 squared plus 2 times negative 3 equals 0. So that would give us 9 minus 6, which equals negative 3. So, or not negative 3, positive 3. So this part is concave up, or a big smiley face. And then let's go ahead and do one in between negative 2 and 0. I think the easiest number is negative 1. So f double prime of negative 1 equals negative 1 squared plus 2 times negative 1, which equals, so that's 1 plus 2 times negative 1. So 1 minus 2 is negative 1. This makes this negative, so a concave down. And then finally, we're going to do this point right here, kind of running out of space a little bit, but f double prime of, let's use 1 because that's super simple. 1 equals 1 squared plus 2 times 1, which equals 3. So this is concave up. So as we can see, our region from negative 2 to 0 is concave down as the second derivative is negative. So that gives us an answer of A. Equals x cubed minus 12x occurs on the interval of negative 3 to 3. So when we're trying to find a max or min on an interval, we want to check both the critical numbers of the function as well as the edges, as the edges won't show up in the first derivative, but they might actually in fact be the max or min. So let's first start by trying to find the first derivative. So the first derivative would be y prime equals derivative of x cubed is 3x squared. Derivative of negative 12x is negative 12. So we set that equal to 0. And then we solve, so it'll give us 3x squared equal to 12x. And then x squared equal to 4. And then x equals plus or minus 2. Make sure not to forget the negative root when you're taking the square root. Okay, so now we have our critical numbers and our edge cases. So let's go ahead and just plug it in to the original function. Plug into the original function will just give us a very clear view of what the absolute max is. So let's go ahead and do that. Y of negative 3 equals negative 3 cubed minus 12 times negative 3. So it gives us negative 27 plus 36, or 9. Let's do 3 next. Y of 3 equals 3 cubed minus 12 times 3, which equals 27 minus 36, which gives us negative 9. And then y of negative 2, negative 2 cubed minus 12 times negative 2. That will give us negative 8 plus 24, or 16. And then y of 2 equals 2 cubed minus 12 times 2. That equals 8 minus 24, or negative 16. So if we look at all of the values of y we found, we can see that at x equals negative 2, y equals 16. Because that is the largest value, our absolute maximum on this interval occurs at x equals negative 2, or A. Number 5, choose the number of true statements regarding the function x squared minus 1 over x minus 4. So the first one says the y-intercept is 0, 1/4. So the easiest way to do that is just to plug in 0 for x. So f of x equals 0 squared minus 1 over 0 minus 4, which equals negative 1 over negative 4, or 1/4. So this is true because y equals 1/4. Number 2, the x-intercepts are negative 1, 0, and 1, 0. So for this one, we can plug in 0 for y because x-intercepts occur where y equals 0. So 0 equals x squared minus 1 over x minus 4. If we multiply x minus 4 to the other side, we get 0 equals x squared minus 1. And then x squared equals 1. And then x equals plus or minus 1. That says that our x-intercepts occur at negative 1 and positive 1, which is what statement 2 says. Okay, number 3, f of x has one vertical asymptote. So when we're looking for asymptotes, we're looking for wherever the bottom or the denominator equals 0. So we can say x minus 4 equals 0, and then x equals 4. So we have one vertical asymptote, so this is true. Number 4, f of x does not have any horizontal asymptotes. So if the power in the numerator, right here, is higher than the power in the denominator of a term with the largest power, then there is no horizontal asymptote. So again, if the denominator has a lower power than the numerator, there is no horizontal asymptotes. So this is true. And then finally, f of x has one slant asymptote. Because the power is bigger on the top than on the bottom, we are likely to have a slant asymptote. Even though this doesn't ask for it, I'm going to go ahead and solve for it. So we need to basically divide the numerator by the denominator using polynomial long division. So if we write this, we can write the numerator, so x squared minus, I like to put fillers when there's no coefficients, so 0x minus 1. All divided by x minus 4. So to get x squared, we need to multiply by 1x, so that would be minus x minus 4x, so, or x squared minus 4x, so that would give us 4x, move the negative 1. We need to multiply by a 4 then, so that'd be plus 4, so that'd be minus 4x minus 16, which gives us a remainder of 15, meaning that our slant asymptote is x plus 4 plus 15 over x minus 4. So that means that there is one slant asymptote. So that means that all 5 of these statements are true, so F is the correct answer. Number 6, evaluate the integral of 6x squared plus 1 over 8x. So a really big thing I like to look for with integrals is if this term is by itself. Obviously, there's nothing added to it or subtracted to it. So we can actually split this up into 2 fractions, making it a little bit easier to integrate. So let's do that. We have the integral of 6x squared over 8x x plus 1 over 8x dx. Again, we just split up this integral into two terms. Now let's simplify a little bit. That will give us 3x over 4 plus 1 over 8x dx. If we take the integral, the integral of first one is 3/4 times when we have x, that's x to the 1, so that means that our final power will be x squared, and then for integrals, we basically put 1 over the new power, so that would be 1 over 2. And then the next term is there's just a leading number of 1/8, so we can take that out. The integral of 1 over x is natural log of x, the absolute value, plus c. So if we look at this, we can simplify a little bit. That would give us 3 over 8x squared plus 1/8 ln x plus c. So if we look at our answers, okay, none of our answers actually match. So we're going to try this again, but the one term that doesn't match up is this 8x right here. So we're going to try this again with trying to integrate this other term. So if we integrate this other term again, 1 over 8x dx. Usually I would just take out the common number, so it's a little weird that this question has that term like that. So, but if we integrate this part, we can basically have a u sub of 8x, so du equals 8 dx, and then dx equals du over 8. If we replace this dx, we would get 1 over 8 integral of 1 over u du. Now, if we integrate that, we get 1/8 ln of u plus c, and then one more, 1/8 ln, replace the u, 8x plus c. Now, both our first term here and this term right here match, so our final answer is 3/8 x squared plus 1/8 ln of 8x plus c. So that gives us an answer of B. Again, I don't really see why they did the problem like this or wrote the answers like this. Normally you could just take out this 1/8 right here before integrating to make it easier to take out the coefficient. Number 7. Given the graph of f, that's supposed to say prime, of x below, choose the correct statement regarding f of x. So because this is the first derivative, let's go ahead and look for critical numbers. That's where f prime of x equals 0. So we can see that there is a critical number at x equals 1 and x equals -1. So let's go ahead and look at these statements. So the first one says there is a relative maximum at x equals -1. Because this goes from positive to negative, so you can see that again in a different color, positive to negative, we know that this will be a maximum because if your slope is going up, you have a slope going up, and then at the max, it will go down. So again, because this slope is going from positive, so that means that it is increasing on this interval to negative. Once it passes x equals -1, there is a relative maximum at x equal to -1. So that means our answer is A, but we can go ahead and just check some of these other ones. F of x is concave up from -infinity to infinity. So if we look at the graph, we can see that there's a inflection point right there. So with the second derivative, so f double prime of x equals 0, f double prime of x equals 0 whenever there is like a part of the graph where you can pretty much have a horizontal tangent line. So there's a horizontal tangent line at x equals 0. Because of that, there has to be a concavity change, so it can't be concave up on the entire interval. So see, f of x only has one critical number. Again, we talked about this when we first looked at this. Wherever f prime of x equals 0, there is where there will be critical points. This, you can see in here that -1 and 1 are critical points, so there's more than one critical number, so that's false. F of x does not have an inflection point. We just talked about this. Wherever the first derivative has a horizontal tangent line is where there's an inflection point. So there's an inflection point at f of x equals 0. So this is not true. And then f of x is decreasing on -infinity to 0. Because the graph is positive for most of that, and then on top of that, it changes sign. It can't be decreasing on that entire interval, so E is false. And then f of x has a relative minimum at x equals 0. That's not true because minimums and maximums only occur where f prime of x equals 0, which again is at -1 and 1, so this is also false. Number 8, evaluate the integral of cosine x minus sine x plus cosecant x cotangent x dx. That is a mouthful. Unfortunately for this kind of question, you pretty much have to memorize the integrals. So if we do it one term at a time, this first one, integral of cosine x is sine x. The integral of negative sine x is plus cosine x, and then the integral of cosecant cotangent is negative cosecant x plus c. So that gives us an answer of D. So unfortunately, when you're doing these trig integrals, there's a very, very high shot that you will make a sign error. So one thing you always have to pay attention to is especially something like this. So the integral of cosine x becomes positive sine x, and the integral of sine x becomes negative cosine x. So if you look at this problem right here, again, there's a negative sign before the sign, so the negatives cancel, so it becomes positive cosine x. So with these questions, make sure you really, really pay attention to signs. Number 9, given y double prime equals 6e to the x plus 6, with y prime of 0 equaling 4 and y of 2 equaling 6e squared, find y of 3. So when you're given the second derivative of something and they're asking for just the original function at a point, we have to integrate to get back to that point. So let's first start by finding the integral of y prime. So the integral of y prime will be the integral of 6e to the x plus 6 dx. That would be 6e to the x plus 6x plus c. So this equals y prime because we have gone backwards one step. The beautiful thing about e to the x is that its derivative is always, or its integral is always e to the x and vice versa, same with the derivative. As for the 6, we just put on an x to break this down again. We have 6 times 1 over the new power, so the new power would be 1 times x. So let's go ahead and find what this original c value is. We are given that y prime is 0 equals 4. So we can plug in 4 for y prime and 0 for x. So that's 4 equals 6e to the 0 plus 6 times 0 plus c. So 6e to the 0, don't be fooled. You can check this with a calculator, but e to the 0 is 1. So 4 equals 6 plus 0 plus c. So that gives us c equaling -2. Now we got to integrate again to find y, so we're going to integrate this with our plugged in constant. So integral of 6e to the x plus 6x plus or minus 2 dx. I'm going to take the integral again. E to the x is just e to the x. 6e to the x plus, this would be 6 over 2x squared minus 2x plus c. Again, I'm going to break down this term for us. We have the original coefficient times 1 over the new power. The new power in this case will be 2 because 1 plus 1 is 2 times x to the 1 plus the new power. So if we simplify this a little, we get 6e to the x plus 3x squared minus 2x plus c. Now, we are given that y of 2 equals 6e squared, so we can go ahead and plug that in here. So I'm running out of space a little bit, so I'm just going to move some things real quick. That's a little bit into our answers, but it's okay. So if we look over here, we get 6e squared equal to 6e. It says y of 2. Be careful, not all of them gives you a nice 0, so make sure to plug in the right number. 6e squared plus 3 times 2 squared minus 2 times 2 plus c. So if we move this to the other side, we have 0 equals 3 times 2 squared, so that's 3 times 4, 12, minus 2 times 2 is 4 plus c. That gives us 8 plus c equals 0. That means c equals negative 8. And then finally, after all of that, we can plug in this c back into our equation to find, and x equals 3 to find y of 3. So we have y equals 6e to the x in this case is 3, plus 3 times 3 squared minus 2 times 3 minus 8. Ooh, that was a little bit of a squeeze. Okay, to simplify, we have y equals 6e to the third plus 3 times 3 squared, so 9 times 3 is 27, minus 2 times 3 is 6, minus 8. We're going to simplify one more time. Negative 6 minus 8 is negative 14, and negative 14 plus 27 is 13. So we have y equals 6e to the third plus 13, where x equals 3, and that gives us an answer of A. Number 10, you have 80 feet of fence to create a rectangular dog run, which will be bounded on one side by the wall of your house. What is the area in feet per second of the largest dog run you can create? So, we always try to draw a picture. That makes life a little bit easier, especially for these optimization problems. So, we have the wall of our house. This is the wall of our house. Because it is bounded by one side of the wall of the house, we only have 3 sides. So we have this rectangle with our sides. So let's label these 2 sides y and these 2 sides x because it's a rectangle, which means both of the sides, the vertical sides, have to be equaling the same thing. So if we reread the question, we see that we have 80 feet of fencing to create a rectangular dog run. So we can make an equation for this. We have x plus 2y equals 80 because that is the amount of feet needed to make this fence. Now, we want to know the largest area we can make, and again, area equals base times height, or length times width, which is x times y. With this equation, we need to basically get this down to one term to find the area. So let's go ahead and do that. With this one, we can actually say that x equals 80 minus 2y. And I think that's a little bit simpler than trying to solve for y. So if we plug in this for x here, we would get 80 minus 2y times y. So remember how our critical numbers, wherever they are equal to 0 is where our max or min is? So we can go ahead and find the derivative to find where that max or min is, because wherever that derivative is equal to 0 is where our critical number exists. So let's go ahead and try to find the derivative of this. We have a prime equals, actually, I'm going to distribute because it'll make it a little bit easier. So 80y minus 2y squared. So now let's find the derivative. A prime equals the derivative with respect to y is 80y. So the derivative of 80y is just 80 minus derivative of 2y squared is 4y. Set this equal to 0, and we get that 80 equals 4y, and y equals 20. So if we use this original equation right here, we can plug this back in. We would get x plus 2y equals 80. So x plus 2 times 20 equals 80. X plus 40 equals 80. That means that x equals 40. Now, again, to find the area equals, again, x times y, or 40 times 80, which equals 800, which means that the largest area we can make is 800 square feet. So with these optimization problems, it's as simple as finding a system of equations to, one, describe whatever your limiting factor is, and two, to describe what you are trying to make the most or least of. Okay. A company's marketing department has determined that if their product is sold at a price of P dollars per unit, they can sell Q equals 1,200 minus 100 P units. Each unit costs $6 to make. What price P should the company charge to maximize their profit? So if we're looking at profit, we know that profit equals the money made off of each item sold times the number sold. So if we can see in our equation, or in our given, we can see that Q, or the number of items sold, equals 1,200 minus 100 P units. So we already have this. The matter is finding this equation. So the money made off of each item sold would be the price minus the cost it is to create that item. So we can say profit equals the price minus 6, again, the money made off of each item sold, times the quantity sold, which is 1,200 minus 100 P units. Now, to find where the maximum profit would be, we need to find the derivative, as where the derivative equals 0 is where the max or min can be. So if we take the derivative of the profit, we need to use chain rule for this one because we have one thing multiplied with another. We'll label this as G, and this is H. G prime times H plus G times H prime. If we do that, G prime is just 1 times H, which is 1,200 minus 100 P, plus G, P minus 6, times H prime, which is negative 100. If we simplify this, we get 1,200 minus 100p minus 100p plus 600. Simplify this again, 1,800 minus 200p. Now again, we said that the maximum profit will occur where its derivative, or the derivative of its function equals 0. So we're going to set this equal to 0. Let's go ahead and solve. We have 1,800 equals 200p, which means p equals 9. So a price of $9 will maximize their profit. Number 12. Matt is building an open-top wooden box for his cat Rupert, who likes to play with boxes. Matt is using wood on all 4 sides and the bottom, and is covering the wood on the bottom with carpet. Matt would like the bottom to have a square base. The cost of the wood is $2 per square foot, and the cost of the carpet is $1 per square foot. Rupert requires 48 feet cubed to have a satisfactory play in the box. What is the minimum total cost of the box? So this is another optimization problem. So let's start by drawing a picture, because boxes have a lot of stuff. So if we draw boxes, the box, we know that Rupert wants the bottom to be a square, so we know that these two side lengths have to be the same, and then the height can be whatever. So we know that Rupert wants a volume of 48 feet cubed, so if we use the variables in this drawing, the volume is width times length times height. In this case would be x times y, or x squared times y. We can set that equal to 48 because that's the size that Rupert wants his box to be. Now, we need to find a equation for cost. When we look at this box, there are 4 side panels, so 4 side panels, and 1 bottom panel. So the top panel is open, so we don't need to worry about the cost for that box. So let's go ahead and write the function for the cost. Cost equals, let's do the side panels first, 4 times the side panels would be have an area of x times y, and the cost would be 2 because there is $2 per square foot for wood. And then plus the bottom panel will have both wood and carpet, so the price is $2 for the wood plus 1 for the carpet times the area of the bottom panel, which is x squared. If you wanted to, you could actually check the units for this. So if you look at this, x times y right here would give you feet squared, and this is dollars per foot squared. So when you multiply the two together, you get dollars only as your only unit. So that's always a really good way to check if you set up these equations right. Okay, continuing, let's simplify. We have 8xy plus 3x squared equals c. Now, we want to find what the minimum total cost of this box is, so we would need to find the derivative of this cost function. However, we can't really derive with both x and y, but we have this equation right here, so we can replace one of our variables with the other matching one in the equation. So if we solve this equation, we would get y equals 48 over x squared. If we replace all the y's in this, we would get 8 times 48 over x squared times x plus 3x squared. So I want to simplify this a little bit. 48 times 8 is 384. So you can plug that into your calculator when you get a chance. And then x over x squared just gives you x plus 3x squared. So that's what our c equals. Now, again, we're trying to find where the cost is minimized, so that's wherever c prime equals 0. So let's go ahead and find the derivative. C prime equals the derivative of 384 over x to the negative 1. So that would be a negative 384 over x to the negative 1. The power minus another 1 is x to the negative 2, so that would be over x squared plus derivative of 3x squared is 6x. We want to set this equal to 0 to find the minimum. And so we're going to move this up here because we're out of space. We can move the 384 over x squared to the other side. So that would be 384 x squared equal to 6x. 6x cubed equals 384. And then let's see, 384 divided by 6 is 64. X cubed, so that means the cubed root of 64 is 4, so x equals 4. So you might be asking, where do we find y? We can find y by plugging back into this. So y equals 48 over 4 squared, so 48 over 16. I believe 48 over 16, let me type this into a calculator fast. 48 over 16 equals 3. And then we can find the cost by plugging this value of x and this value of y back into this original equation right here. So c equals 8 times 4 times 3 plus 3 times 3 squared. So 8 times 4 is 32, times another 3 is 96, plus 3 times 3 squared, so 3 times 9, 27. So 96 plus 27 equals, oh shoot, I plugged in the wrong value for that second part. Let me fix that real fast. We have 4 squared. So that first part is 96 plus 3 times 4 squared. 3 times 16 is 48. So 96 plus 48. And we're running out of space. 96 plus 48 equals 144, or an answer of E. So again, with these optimization questions, you're going to find a system of equations where you solve one simpler equation for a variable and then plug that, substitute that in for the other variable in your other equation.